Metals and nonmetals. Introduction. Elements can be classified as metals and nonmetals on the basis of their properties. Only 17 elements in the periodic table are generally considered nonmetals compared to over 80 metals. Physical properties of metals and nonmetals. Metals and nonmetals have different physical properties. They are stated here in the form of a table. Read on. Chemical properties of metals and nonmetals. Metals and nonmetals have different chemical properties. They are stated here in the form of a table. Read on. What happens when metals are burnt in air? All metals combine with oxygen to form metal oxides. For example, when copper is heated in air, it combines with oxygen to form copper oxide, a black oxide. The order of reactivity of the metals with oxygen can be expressed as shown here. What happens when metals react with water? All metals react with water to form metal oxides or metal hydroxides. Hydrogen gas is released in this reaction. Metal oxides are basic in nature. When dissolved in water, they form an alkaline solution. The order of reactivity of the metals with water can be expressed as shown here. What happens when metals react with acids? Most metals react with dilute acids by replacing hydrogen and forming a salt. Hydrogen gas is released. With dilute hydrochloric acid, metal chloride and hydrogen. Some examples are given here. With dilute sulfuric acid, metals react to give metal sulfate and hydrogen. Some examples are given here. The order of reactivity of the metals with acids can be expressed as shown here. Metals like copper, silver, gold, platinum, and mercury do not react with dilute acids. How do metals react with solutions of other salts? Reactivity of metals determines which salt is formed when a metal is added to a salt solution. More reactive metal displaces the less reactive metal in the metal salt. These are called displacement reactions. Some typical examples of metal displacement reactions are shown here. The reactivity series. The reactivity series is a list of metals arranged in the order of their decreasing reactivities. Hydrogen has been included in the table here, although it is a nonmetal. Hydrogen, like metals, gives off an electron while forming bonds. Metals which are more reactive than hydrogen can displace hydrogen from water or dilute acids and liberate hydrogen gas. Metals which are less reactive than hydrogen do not replace hydrogen in a reaction with water or dilute acids. From the reactivity series of metals shown here in the table, we can say that metals that are more reactive than hydrogen are placed above hydrogen. Metals whose reactivity is less than that of hydrogen are placed below hydrogen. How do metals and nonmetals react? Ionic bonds form when metals and nonmetals chemically react. For example, in the reaction between sodium and chlorine, each chlorine atom takes one electron from a sodium atom. Therefore, each sodium atom becomes a cation, Na+, and each chlorine atom becomes an anion, Cl-. Due to their opposite charges, they attract each other to form an ionic network or lattice. The formula ratio of positive to negative ions in the network or lattice is NaCl. Properties of ionic compounds. Ionic compounds are a combination of positively charged ions, cation, and negatively charged ions, anions. The general properties of ionic compounds are listed here. Physical nature. Ionic compounds are hard solids. Melting and boiling points. Ionic compounds have high melting and boiling points. Solubility. Electrovalent compounds are generally soluble in water and insoluble in solvents such as kerosene, petrol, etc. Conduction of electricity. Ionic compounds conduct electricity when they dissolve in water. Occurrence of metals. The Earth's crust is the major source of metals. Seawater also contains some soluble salts such as sodium chloride, magnesium chloride, etc. The elements or compounds which occur naturally in the Earth's crust are known as minerals. Extraction of metals. Extraction of metals from below the surface of the Earth forms a major industrial endeavor. Naturally occurring materials or compounds which are a combination of metals with other elements are called minerals. Minerals are found amongst rocks and stones inside the Earth's crust. Such rocks and stones are called mineral ores. Ores have to be mined, crushed, and metals have to be extracted from them by various chemical processes. The various steps involved in the extraction of metals from ores are represented here. Enrichment of ores. Unwanted rocks, sand, and grit from the mineral ore are called gangue or matrix. Depending on the type of the ore, hydraulic washing, froth flotation process, magnetic separation, and chemical separation techniques are applied for enrichment of an ore. Extracting metals low in activity series. Metals low in the activity series are very unreactive. The oxides of these metals can be reduced to metals by heating alone. For example, copper, which is found as Cu2S in nature, can be obtained from its ore by just heating in air. Extracting metals in the middle of the activity series. The metals in the middle of the activity series, such as iron, zinc, lead, and tin, are moderately reactive. These are usually present as sulfides or carbonates in nature. The sulfide ores are converted into oxides by heating strongly in the presence of excess air. This process is known as roasting. The carbonate ores are changed into oxides by heating strongly in limited air. This process is known as calcination. The metal oxides are then reduced to the corresponding metals by using suitable reducing agents such as carbon. Extracting metals towards the top of the activity series. The metals high up in the reactivity series are very reactive. They cannot be obtained from their compounds by heating with carbon. For example, carbon cannot reduce the oxides of sodium, magnesium, calcium, aluminium, etc. to the respective metals. This is because these metals have more affinity for oxygen than carbon. These metals are obtained by electrolytic reduction. For example, sodium, magnesium, and calcium are obtained by the electrolysis of their molten chlorides. The metals are deposited at the cathode, the negatively charged electrode, whereas chlorine is liberated at the anode, the positively charged electrode. Refining of metals. Free metals obtained by various reduction processes may have several impurities which may be other metals. The most widely used method for refining impure metals is electrolytic refining. Many metals such as copper, zinc, tin, nickel, silver, gold, etc. are refined electrolytically. Corrosion. Corrosion is the atmospheric oxidation of metals. By far, the most important form of corrosion is the rusting of iron. Rusting is essentially a process of oxidation in which iron combines with water and oxygen to form rust, the reddish-brown crust that forms on the surface of the iron. This type of damage usually affects metallic materials and typically produces oxides and or salts of the original metal. Prevention of corrosion. The rusting of iron can be prevented by painting, oiling, greasing, galvanizing, chrome plating, anodizing, or making alloys. Galvanization is a method of protecting steel and iron from rusting by coating them with a thin layer of zinc. Alloying is a very good method of improving the properties of metal. An alloy is a homogeneous mixture of two or more metals, or a metal and a non-metal.